When you've been running for a while, your legs might start to get hurt, so pain receptors might begin to activate. Your central nervous system kicks in and dumps the neurotransmitter enkephalin on opioid receptors. Enkephalin is a naturally occurring neuropeptide that is an inhibitory neurotransmitter that stops an action potential from occurring. This allows the muscles to relax, alleviates pain, and results in what is known as runner's high. Now let's look at this on a cellular level. At rest, there is a large concentration of sodium ions outside the neuron, and a large concentration of potassium ions on the inside of the neuron. In addition to the potassium ions, there are also many amino acids and other ions that carry a negative charge inside a resting neuron. This results in a net negative charge on the inside of the cell and a net positive charge on the outside of the cell. This balance is maintained by the sodium-potassium pump, which removes 3 sodium ions for every 2 potassium ions brought in. The neuron receives a signal from the brain from the stimulation of the dendrites. The axon hillock triggers depolarization. The sodium channels at the axon hillock open, causing sodium to rush in and reversing the charges of the cell at that particular spot. All other sodium channels are closed, meaning that the charges aren't reversed in any other spot. This reversal of charges causes the adjacent sodium channel to open, and charges to reverse at that spot as sodium enters the neuron. Depolarization is followed by the repolarization, which is the restoration of the resting potential. Potassium channels open, and potassium flows out, and sodium channels flows out, reversing the charges so that the inside of the neuron is more negative than the outside. The sodium-potassium pump restores the ion equilibrium by pumping 3 sodium ions out of the cell for every 2 potassium brought in. The action potential travels along the axon and is immediately followed by repolarization. It jumps between the nodes of Rampier in saltatory conducts. An action potential cannot travel through myelin sheaths because they are made of fat and do not allow any ions to pass through. When the action potential reaches the end volt, the charge reversal causes voltage-gated calcium channels to open. Calcium rushes into the cell, which triggers the release of synaptic vesicles. Synaptic vesicles that contain the enkephalin fuse with synaptic membrane and releases the enkephalin in the synapse. The enkephalin binds to the opiate receptors, which alleviates the pain, causes the muscles to relax, and give a temporary feeling of a high. The enkephalin in the synapse is removed by the NEP1 enzyme and replenished by the proteins in the cell body of the neuron. The sodium-potassium pump continues to work until the ion concentrations are restored. Thanks to enkephalin, you aren't completely tired after your 50-mile run. Yay.